Hi guys, this is probably going to be my last video for today, but this one I'm just going to go over this question here that talks about finding the mean and then finding the standard deviation. So these white dots that you'll notice here, and that's just, I was whiting out some answers that were already on the page. Didn't want to get us confused with that, because this is just a picture of the page itself. I'm sure you can tell. But the first question here is asking what the mean is for sample A. These are our samples here. This is sample A. So the way we find the mean is, oops, that was way too big. The sum of x over n is the number of, sorry about that, is the number of responses you had. In this case, it's the number of students. So we had 10 students. So it's going to be the sum of x over 10. And then I'm going to go ahead and do the sum of x now, which basically it's just this. Sum of x equals all that. So I'm going to plug this into my calculator. 28 plus 30 plus 33 plus 35 plus 40, 40 again, 45, 50, 50, 55. I got 406 over 10. But I am going to go ahead and do that one more time just to make sure I didn't enter anything in wrong. Sometimes I'll mess up and press the wrong number on a calculator and then throw all my stuff off, so it's always good to double check. But looks like I was right on that one. I got 406 again. So now we're just going to do 406 divided by 10, and that is 40.6. So the mean for sample A is 40.6. I'm going to go ahead and highlight that answer. Next question here, what is the mean for sample B? We're going to do the exact same thing for that one. So I guess I should be writing X bar on there. This is the symbol for the mean of a sample. Same formula. 1, 2, 3, 4. Yep, so it's also going to be 10. So now I have to add up these ones. So that is going to be 401, it looks like, which is 40.1. So that is our mean for sample B. This question says, based on the two means, does it appear that one group is more accurate than the other? So this is about taking a test. So more accurate would mean like got more answers right. But by looking at the means and comparing them, 40.6 compared to 40.1, that's, really close to each other. So I'm just going to put no. Like those are pretty close, so it doesn't seem like one is a lot more accurate than the other. Which in a little bit, you guys will learn all about how to find that in a more statistical type way, not just glancing at them, but finding out if something is statistically significant. So 11D here, this asks for the standard deviation for sample A. I'm going to go over to my formula sheet here. This is a sample, so we're going to use the sample formula. So it says, oops, sorry, that's an old one. It says S equals the square root of that. So this is, S is standard deviation. This is the square root of S squared, which is variation. But we don't have S squared, so we need to go find S squared. So the variance for a sample is sum of squares over n minus 1. So but we also don't have sum of squares, so we've got to go find the sum of squares formula, which is sum of squares equals sigma x minus x bar squared, and we have x bar. X bar is 40.6, because remember that this means the mean of the sample. So we will be using 40.6 as the mean there. But actually, let's look at this instead. Would this be easier? Okay, we'll actually use the computational formula. It's actually really a lot, it's a good idea anyway that you see how to do it in multiple ways. And I think it's going to be faster to do it this way for sum of squares. So sum of squares equals x sigma x squared minus sum of x squared over n. Alrighty, so the first thing we have to do for this one is find x squared for each value, and we're using sample A. So I'm going to do my calculator here. $28 squared is 784. 30 squared is 900. No. Yes? I don't know why I doubted myself there. $33 squared is 1,089. 35 squared $1,225. 40 squared 1,600. Again, 40 squared 1,600. 45 squared 2025. 50 squared is 2,500. again 2,500, and then 55 squared is 3025. Okay, so this here is our sum of x squared. Which, for the sum of x, we decided was 406. Realized I forgot to write that out there. Okay, anyway, so next thing I'm going to do is I'm going to add up all of these results here and see what I get. So 784 plus 900 plus 1089 plus 1225, 1600, 1600, 2025, 2500, 2500, 3025. Okay, so it looks like that is going to be, use pink here so we're being consistent, 17,248. Okay, so that is our sum of x squared, and then this is our sum of x. So, the sum of x squared here is what we just found, which was the 17,248 minus. So this here is the sum of x, which was that first thing that we found way earlier, which was 409. So what we did for that, remember, is just we added up 28, 30, 33, 35, 40, and so on, and that gave us, oh, I said 409, but I meant 406, sorry. That gave us 406. And then we said that that n was 10, since that's how many people were in our sample. So now we're going to do 406 divided by 10, which is 40.6. And then we're going to do 17,248 minus, oh wait, sorry. I skipped a big step here. Big step. I was like, what the heck? What we need to do before that is 406 squared. So 164,836, and then divide that by 10. There we go. So that gives you, move this over so we have room. So that's going to give you 16,483.6. Then we've just got to do this 17.28. So sorry, I just like to keep this rearranged so that you're not going to get really lost on where our work went. So here's our sum of squares, formula, I'll just put that there, you guys know what I mean, right? Okay, so now we're just going to do that 17,248 minus 16,483.6, which is 17,248 minus 16,483.6 is 764.4. Like I said, the next thing we're going to do is, before we can find the standard deviation, we have to find the variance, which that's this formula right here. We just solved for the sum of squares, which was 764.4. So I'm going to put that in my numerator as the sum of squares, so 764.4. Our denominator is n minus 1. We said our n was 10 because that's the number of people that were in our sample. 10 minus 1 is 9, and then I'm just going to divide that 764.4 by 9. That gave me 84.93. So that is our variance was 84.93. So now, I put variation instead of variance. Sorry, it's 6 in the morning. I'm tired. But this here is what the question actually asked us to find, which was the sum of squares, which is just, oh my goodness, guys, I'm messing up all over the place. What we were actually asked to find is this value here, which is the standard deviation. So the standard deviation is the square root of the variance, which was that 84.93 that we just found. So I am just going to use my calculator to find the square root of that 84.93. And that gives me 9.22. So our answer for that one is 9.22. And then the next one, we're going to do the same exact thing, except we're going to do it for sample B instead of sample A. So I'm actually not going to run through this just because it's going to be the same exact thing as this. If you guys want more practice with standard deviation, let me know and I can do some more problems. But I don't want this video to get crazy long. So I'll just go ahead and tell you that the standard deviation for sample B was 2.56. So if you try it out on your own and you don't get 2.56, then that's, a good indicator that you need some more practice with standard deviation, and I could just leave a comment and I can make some more videos on that. So our final question on this one asks, which group is more consistent, meaning has less variability? So the one with less variability is going to be sample B, since the standard deviation was smaller, and our standard deviation represents variability. So I hope that this was helpful.